Dear friends, welcome to my video. In this video, I will show you how to compute the sum of the factorials of n natural numbers. So you give an input n and this and I will compute the sum of the first n natural numbers starting from 1 to n. I'll try to solve it using MATLAB and Stateflow both in this video, but my main intention is to show you how to do it in Stateflow. I'll just quickly in the first few minutes I'll take you through MATLAB code, which is very simple and straightforward, but my main intention is to show you how you can do it very easily in Stateflow as well. If you are looking for a video where you just want to compute a factorial and not a sum of factorial, then please view my other videos, the link for which I will be giving above and also in my description. So in those videos I have shown you how to compute the factorial of n natural number of not the sum, only the factorial of nth number using MATLAB, Simulink and Stateflow, all three formats. There I have shown you in detail how you can do different kind of programming in MATLAB, like recursive programming and iterative programming. But in this I'll keep the MATLAB coding simple and I'll just focus mostly on Stateflow. Some of the part of Stateflow may be repetitive, but that may be important. But it will be important to understand the complete how we derive to the uh, sum of the factorial. Okay. So before I start, so what is the sum of the factorial? So say for example, if you want to find the sum of the factorial of when n equal to 4. So when your n equal to 4, you want to find the sum of factorials of n equal to 4. That means you want to find the factorial of 1 plus, I'll just do a copy paste, Ctrl C, Ctrl V. So factorial of 2, Ctrl V, factorial of 3, Ctrl V, and factorial of 4. So this is basically what we mean. We have to do the summation of all the factorials up to 4. So this is what we will do. Basically, it looks simple. In MATLAB coding, it will be very simple because this is basically what we have to do. But in Stateflow, it may be a little tricky. But initially, we will quickly create a MATLAB function and we'll show how we can do it. So we will have just one output argument, which will the some result, and we will have one input argument. We don't need two, as I have done in my other video. The MATLAB function name, probably I can keep it as factorial underscore sum. Yeah, and that's it. First let me save it. Factorial sum.m. The file name and the function name should be same. I hope most of you should be aware of this. I just delete this, and yeah, probably I'll just delete these two lines also. I don't need this unnecessary confusion. Okay, so to find the sum of the factorial, what we'll have to do is we'll have to have a for loop where for will I equal to 1 and until my this input argument variable. Yes, and then in between I can do what I can do is output. Oh yeah, but initialization of output argument should not be equal to input argument, but we'll start with 0 because we initialize it with 0 because we need some value, garbage value or whatever you can say, and then we iterate it into the loop, and then output argument will be nothing but output argument equal to the sum of output arg plus the factorial of input arg, factorial of input argument. Yes, that's it. This should work. So let me call my above function factorial of sum with 4. My value should, I'm expecting 33 to be output. Okay, so here it gives 96. So let's try to understand. So let's try to understand what's gone wrong here. So one way is you can debug and see, or other way is just like try to scan. It should be a very simple program, and the place where I think see major algorithm is happening in line number 6. So what we are doing over here is we are iterating through one by one all the elements, and then we are summing up the elements with the output argument which is initialized to 0, and we are summing up the elements one by one to that level. But yeah, here is a mistake. So what, if you observe, what we are doing is we are always taking the factorial of input argument, which is 4. So factorial of 4 is 24. So we are adding up to 24, and that's also 4 times, because the loop will run for 4 times. So 24 into 4 is 96. That's why we are getting 96. So to rectify this, we have to change it to I, because that's our index. And now if we use this, yeah, now we get 33, because now it, in the first iteration it will find the factorial of 1, in the second iteration it will find the factorial of 2, and so on. For the fourth iteration it will find the factorial of 4. So summation looks good to me. So just a quick check we can do for factorial of 5, which is 153. So factorial of 4 is, sum of factorial of 4 is 33. The fifth factorial is 120, so 120 plus 33 is 153. We can find for a smaller number also, because it will be easy for us to comprehend. And factorial of 3 is like 9 also. So 3 is 6 and 2 is 2 and 1 is 1. So 3, 6 into plus 2 plus 1, 8, 8 and 9. Yeah. So that's correct. Yeah. So anyway, so this is a very simple example I wanted to show. And if you observe that even for the simple one, we tend to do mistakes sometimes. So it's not a problem. So my main intention was to start or show or to do this in a state flow diagram. So let me do it in a state flow. So let me create a new Simulink model, simple one. I just first save it. Factorial sum state flow. I just put SF here. Okay, so now I include a chart here, a state flow chart. And probably what we'll need is we'll need an input to this, because the input will, okay, so as I showed in my last video as well, we can take a local variable also for this input argument value, but over here I prefer to have an input variable separately. So I'll go and add input from Simulink, data input from Simulink, and probably I'll name it as variable as input. Yeah, that should be fine. And also I will like to go for an output argument to Simulink. I'm not sure why this is blacked out. Probably some resolution factor is playing out here, but that's fine. I think this is simple. You can just click OK here. So now if I go back one level up, you can see the input and output drawn here or shown here. So as an input I can give a constant block. You can also use an input block or something. To start with, we'll just put 4 as a value, because we know the sum of factorial of the sum of factorial of 4 is 33. We did this experiment just above, so we should expect the output as 33. To get the output, we can use probably a display block, which will just decimation we don't need, because anyway we will have integers. Yeah. So now we have input and output variables. Now we can go and design our state flow. So to design our state flow, first let me put this, the starter node, and then what we can do is, yeah, but we also need some local variables. So for local variables, probably what I will need is, I'll need 2 local variables. One is to find the factorial, because although in the MATLAB script it was simple to find factorial, I'm not sure in Stateflow we can use the same API, but in my Stateflow I will try to compute the factorial also recursively, or not recursively, but in an iteration. So I will need a local variable to compute a factorial, and the other variable I need is to compute this summation, which we are doing it here in the MATLAB code, which you are able to see here. So let me define 2 local variables here. I define other elements and local data, and I can define probably the factorial or let me have just okay, let me have some completely factorial. I click OK here, and in the second one I can go and define as factorial, sum of factorial, or sum underscore fact. Yeah. So those 2 local data we have got now, and probably we'll also need one more local variable which will the output of the factorial. So probably we can take that we can have a iteration factorial. Probably these names are a little confusing, but yeah, you'll figure out when we start designing our this. Okay, so now we have our first transition. So in this transition, the things which we'll need is, of course, there won't be any condition. We'll just directly move to the action. But before we go, let me have no. Sorry, I don't need this. I'll just delete this. What I need is I just need one more. Yeah. So if you see in this one, you can have either condition or action. But for the first node, if you are aware of Stateflow, you can't have this one condition, because you can't have any condition. It has to always go through, and you can just have action. So that will start here. So I will have some action here. Action will be mostly, but what we'll have to do is we have to initialize our stuff. So one was our main output and the input. So I'll just do one more thing for the simplicity. I'll open the Model Explorer so that you are aware of all your variables which you have defined. So your output and input. So I'll put output as 0 because summation has to be 0, and then the factorial output will be equal to 1, and iteration of factorial will start with the input. So input, so in this Stateflow will go the other way around. So in MATLAB code, if you saw, what we did was we first took the factorial of 1, then 2, then 3, then 4, and then we added it. But in this Stateflow, we are going the other way. We are first taking for 4, then 3, then 2, then 1. So that's why we are starting with input over here as an initialization condition. Okay, and what else? So we had one more local variable, if I remember it correctly, and it's sum factorial. So I think the name is a little confusing here. Probably let me rename it to not sum but iteration sum. Name is becoming longer, but I think that's sometimes important to understand. So I come back to my Stateflow and put it iteration sum fact, and this will be equal to I think this will also equal to input initially. Yeah. So once I have defined this, all these things, now what we can do is yeah. So in the first part, we'll concentrate on how to design the factorial part, which although I've shown in my other video, but I'll repeat it here. So over here in the first iteration, I'll go for factorial. So I'll first mostly concentrate on the iteration for factorial and in the summation of factorial, and that will sum it in the output in the second iteration. So let's start. So over here, in terms of condition, we'll have nothing, but in terms of action, what we'll have is we'll have the factorial. So I will have first I'll decrease the iteration of okay. Oh yeah, but before we subtract it, we should multiply, I mean the output of factorial, which will be nothing but factorial equal to factorial into, and we'll go for this iteration. Yeah. So if I'll explain it again what I am doing here. So in this transition, first we are multiplying the factorial with the iteration fact. So that's why we get the multiplication. So say for example, if we start with factorial of 4, so iteration factor initially will be 4, so 4 into 1 will be 4, and over here we are subtracting by 1, so it will become 3 over here, and in the next iteration it will again do for 3, then 2, then 1. So that's how we are doing it. So in this reverse transition, we'll do a condition check that whether my iteration factorial is greater than 1 or not. If it's not greater than 1, there is no point going back again, and of course we'll have one more to end the transition. So as far as I understand, this will more or less work as my factorial loop. If we can do a quick check as an intermediate check, so it should return the value 24 here is what I'm expecting. It returned 0. So let's see where it is going wrong. Okay, so to understand why it's giving a 0 value, let's go inside our chart and see what's going wrong. Yeah, so inside the chart we can see our output variable is initialized to 0 and nowhere we are updating it the value. So to quickly get the value as an output, what we can do is here we can before exiting the state flow, we can have this output updated, the value of output, and that we can do is output should be equal to factorial, whatever the factorial in that loop it is, we will update it to factorial. So if I know, if we simulate this again, yeah, this is fine. So now if I go back and simulate again, no, it should give 24. Yeah. So as I told, like initially we have designed just one loop where we are finding the this one, finding the factorial of the nth number. Now let's have one more loop where we'll do the summation here. So for that, what we will have to do is, yeah, in this second iteration we'll have one more iteration from here till here, and in this, so here what we'll do is our output will be nothing but it will be the summation of output, sorry, yeah, output will be sum of output plus factorial whatever we have defined here, and our iteration, the iteration of sum of factorial should reduce by 1. So iteration sum fact should reduce by 1. So we go for factorial of sum and we subtract it by sum factorial minus 1. I know we can't see it, so I just probably I can make it full screen. Yeah, no, it should be fine. So in this loop, what we are doing is initially first we take the output, we update the output value, and then we subtract the iteration of this. So basically we started with the 4, and then we know we'll do it for the 3, then 2, then 1. So that's how we'll do. So in this loop, of course, initially we'll check the condition again, and condition should be that our this iteration of sum of fact should be greater than not 1 but 0, because we have to do the 1 also, the first element also, although the value will be 1, but we have to do it, and the value of the factorial will be 1 for 1. Okay, so as long as greater than 0, we have to keep doing this loop, and in this action will be one thing which we have to note is this iteration is for the summation of factorial, but we have to update our iteration of the factorial, which is here we have put it for input, which is like for our case this case is 4, but we have to subtract it by 1. So either we can subtract it over here, or we can directly use whatever we are getting it over as this one, iteration of sum factorial. So I will prefer to directly use the this equal to iteration of sum of factorial. Yeah, so this will take care of it. So basically what will happen is first time it will be 4, then second time it will be for 3, so it will reach 3 here as an initialized value. It will find the factorial of 3, it will give it output here for 3, then for 2, then for 1, and that's it. And I think one more thing which we may have to do is, if you notice here, we have initialized the value of factorial equal to 1, so I think we will have to initialize that also over here. Yeah, otherwise it would might be a blunder. Yeah, and that's it. And then we have to just make a end loop. Now let's try to simulate and see. Let's go one level up and simulate and see what the output is. 33, perfect. So this is what we were expecting. Now let me change it to some other value. Let me change it to 5, and the factorial of 5 was, I think it was 153, because the factorial of 5 is 120, and till 4 the summation is 33, so 120 plus 33 should be 153. 153, perfect. We'll go for some smaller value, so it will be 3. Okay, I don't know why by mistake I entered comma. It should be 9, I think. Yeah, it's 9. So if you see, although I had some struggle over here to understand different variables, but once you have all the variables defined nicely, then you have to just make this two iterative loop over here, and you can easily just get the sum of the factorials in the Stateflow. So just to summarize quickly, to design the summation of factorial in your Stateflow, you need 2 iterations, and you need 4 local variables. One local variable is to find to keep the count of the first iteration, in which you find just the factorial, and the second local variable you need to find the iteration of the second loop, where you are keeping the count of the summation of factorial. And other 2 local variables you need is, one is to keep the factorial local variable, local data, and you need to keep the out this one iteration. Okay, so you just need and the third other one will be to find the iteration of the factorial. So these are the basically variables, local variables you will need to design your Stateflow chart. And you can see the local variables and all your input and output variables as over here. The output will be to give the to keep the output of the summation of the factorial. Okay, so I hope this video is helpful to you. You can understand how to design a Stateflow chart for various demo examples, and this is one of the good examples where you learn how to define different transitions and nodes for the in a Stateflow. And of course we designed our first the MATLAB function also for this factorial. This also would be helpful to you, I guess. So I hope you like this video, and if you have any questions or comments, please put in the comment section. And if you like this video, please subscribe to my channel. And before I end, I will repeat, I have made a couple of videos where I have shown how to compute factorial in MATLAB, Stateflow, and also Simulink. The links for which will be given in my comment section or description section. Please go through that also. In that I have gone in detail of this first loop, and also I have shown you various techniques of computing the factorial in MATLAB. 2-3 approaches I have shown. So please go to that video if you are interested. Thank you for watching this video, and have a nice day. Bye.